Hi, I'm Utkarsh Mal and I'm presenting our work Discovering Underground Maps from Fashion. This work was done in collaboration with Kavita Bala, Tamara Berg, and Kristen Grauman. Cities are traditionally divided into multiple neighborhoods, where boundaries occur due to many reasons such as city governance or geographical separation. However, a person who knows a city well often has a different notion of neighborhoods than these. To take New York City as an example, Lower Manhattan is a neighborhood in traditionally drawn map, but Lower Manhattan is a diverse region encompassing corporate offices near Wall Street or campus for New York University. Often, such information is hidden and known only to the locals. Underground guides reveal such information as they are written by locals or experts of a city. In this work, we answer if we can get such underground neighborhood maps for a city. Such notions of neighborhood can be more useful than a traditional neighborhood division, as they reveal how neighborhood actually is perceived and experienced. People's clothing is a strong indicator of their personal styles, interests, and current activities. It can reveal information about how a neighborhood is perceived. For example, people dress differently based on the activities such as dressing as a tourist, or for nightlife, or for beaches. Therefore, we leverage the dressing sense of people to discover these neighborhoods. We take a large data set of images with geotags as input for a city. We use an attribute recognition model to discover discrete popular styles such as people wearing white t-shirts and caps or people wearing black hoodies. Then, in order to describe a location on a map, our method picks images within some threshold radius of that point. Using the discovered style, we bin these images within the region to create style histograms as the descriptor for the location. We do this for all the locations where we can get enough images. Then we cluster these descriptors to find underground neighborhood maps with similar styles. We now look at the results of our method. For quantitative evaluation, we create two benchmarks. The first looks at a city subjectively and uses people's perception to create a neighborhood labeling called the HM benchmark. The second looks at a city objectively and uses real business density to get labels called the BD benchmark. We evaluate our method and baselines by measuring the clustering agreement with these two benchmarks. We first evaluate agreement between the traditional map and the benchmark. Normalize mutual information, cluster purity, and mean maximum IOU are the three metrics that measure the agreement between the two sets of clustering. Using underground maps instead of traditional map leads to better agreement with the values in these benchmarks. Here we show an example of an underground map for the city of Austin. The traditional map has neighborhoods based on administrative boundaries such as those separated by rivers. Whereas an underground map can capture much more about a city. For example, it can find out a neighborhood around a university or area popular for nightclubs. We can find the most unique neighborhood using the histogram of that neighborhood. A unique neighborhood is the most distinct neighborhood from all others in the city. The neighborhood N in a city C is unique if it is farthest apart from all other neighborhoods in its fashion sense. For Los Angeles, the unique neighborhood has people wearing very specific blue shirts and hats. This is because of the presence of Dodger Stadium and its fans in the area. We can also find similar neighborhoods across cities. We measure the distances between histogram descriptors of a neighborhood from two cities to find similar neighborhoods. For example, we can say that Bondi Beach is closer to Brooklyn than Coney Island. If the cities themselves are very different due to the culture or the climate, as is the case here, the distance on its own is not very meaningful. Instead of measuring distances, we measure the distances in relation to the overall histogram of the city. This can be thought of as finding the neighborhood that satisfies the analogy with respect to the city. If we use distances between histograms to find similarity, it cannot find a useful neighborhood. Whereas using the analogical distance, we can correctly find the tourist neighborhoods of Rome by using the tourist neighborhood of Istanbul. To conclude, we presented a way to automatically create underground maps by leveraging the fashion sense of a place. We show that underground maps capture useful information that is fundamentally different from traditional maps. We present methods to find unique neighborhoods and use analogy to find similar neighborhoods across very different cities. Thanks for listening to this talk.